Hola amigos. In this video, I want to review gas stoichiometry with you a little bit, just kind of go over one more of our more difficult problems. And then I want to just teach you a little bit about how we can use the ideal gas law in a new way. All right, so last video you watched, you learned that there are two ways to do gas stoichiometry, and it depends under what our temperature and pressure conditions are. If we are at STP. So for instance, here's kind of a hint with number 7. So number 7 tells us that exhaust fumes are sometimes used to fill large airbags. And we want to know what mass of C8H18 must be burned to fill that 1.4 liter airbag. I'll give you guys a hint. And then it tells us that our wrecker truck burns at STP. STP is standard temperature and pressure. And when we are at STP, remember, we can use that 1 mole of any gas is going to have that volume of 22.4 liters as a conversion. So we can just plug that in to do our stoichiometry to change liters to moles and then our mole ratio. But let me kind of use number 8 as a way to kind of review our second method. So number 8 tells us that if we have 34.6 grams of zinc reacting with an excess of hydrochloric acid at standard pressure, what is the temperature of hydrogen gas produced if it occupies a 2-liter container? So for this one, it's kind of a bit weird. We want to know temperature, and we're told it's at standard pressure. So again, we see STP, we see standard pressure, we should automatically think that's 1 atmosphere. We want to know temperature, and we're given volume. So let's think about this. It's stoichiometry. We have pressure. We are given a volume. We're trying to find temperature. So that kind of gives us a big hint here that we have to use PV equals nRT. We have a pressure. We have a volume. We know R. T is our X. And then the last thing we need to plug into PV equals nRT is moles of the gas. So we got to be careful here. Zinc is a solid, so because it's a solid, we can't use it in PV equals nRT. We need to do hydrogen. So let's think about this. We're given grams of a solid, but we have that equation. So let's do some stoichiometry to convert grams of zinc to moles of H2 hydrogen gas. So I'm going to do my molar mass of zinc. Put that over 1. Molar mass of zinc, what, 65.38, I believe? Or is it 63? Well, I gotta double check this real quick. I am just briefly looking up the molar mass of zinc. Oh, 65.38, I was right, that's good to know. And that's grams. And then because we have that balanced equation, for every 1 mole of zinc, looking at my coefficient, that's why it's a 1 for zinc, I make 1 mole of H2. So let's do the math and let's figure out how many moles of hydrogen gas we have. So 34.6 divided by 65.38, and I get 0.529 moles of H2. And so now I can plug my moles of H2 into PV equals nRT. Standard pressure is 1. Volume of the container is 2.00 liters. Moles is 0.529 moles. R I know is 0.08206, and I'm going to go leave off the crazy units there. And then T is our temperature. So 1 times 2, and then divided by, inside of parentheses, 0.529 times 0.08206. You can make sure that's inside of parentheses. And then our temperature would be, I think with 3 sig figs, 46.1. And then our units should be Kelvin. So again, that was kind of a tricky one there as we took a look at that. The key was kind of recognizing that we have pressure, we want temperature, and we're given volume. And we're told how much we have of something, so we should be thinking ideal gas law with PV, N, and T in the problem. And then us realizing, oh, we can't start with Pivner. We have to do stoichiometry to get moles of the gas, which we can then plug in to PV equals nRT. And that was just like, I think, number 5 that I worked in video number 1, where we were given grams of carbon monoxide, and we wanted to know volume of a gas. So we did stoichiometry to get moles, then we plugged into PV equals nRT. One thing that was different, we weren't solving for volume. In this case, we were solving for temperature. But the idea is the same. We were given the pressure, the volume. We could do stoichiometry to get N, and then PV equals nRT to solve for temperature. I know, kind of a mouthful there. All right, a little more help with number 9. It's going to be another stoichiometry, then into PV equals nRT. A little hint here that 1 kilogram, that's the same as 1,000 grams of octane. That is going to be your given. I would take 1,000 grams of octane and change it to probably moles of O2, and then into PV equals nRT. And then let me talk about number 10. So number 10 is one of those new problems. A sample of gas with a mass of 2.92 grams occupies a volume of 426 milliliters at 0 degrees Celsius and 1 atmosphere's pressure. What is the molar mass? So let's think back. We've done problems like this a lot. We did it in the acid-base unit. We've done it in some other units. So let's just remember here that our molar mass formula is grams per mole. Remember, that's how we calculated it before. So if we think about this, we have grams there, right? We know how many grams are in our sample. So to finish this calculation, we need to get moles. So you might be asking yourself, how can we get moles? Well, with acid-base, remember it was MeV equals MeV. But with gases, it's a little bit different. If I take a look at here, I see a volume. I see a temperature. I see a pressure. Let's write that a little bit nicer there. Pressure. And I want to find moles, which is N. So some of you are probably just screaming at the screen right now, use PV equals nRT. And that's exactly what we're going to do. We're going to use Pivner, the ideal gas law, first to solve for moles and then plug in. So let's plug in. So we have our pressure, atmospheres, we have our volume, and be careful, volume for the ideal gas law needs to be in liters. So divide by 1,000. And that's equal to N, which we're trying to find, R, and then our temperature is 0 Celsius, which is 273 Kelvin. Don't forget, temperature has to be in Kelvin. So 1 times 0.426 divided by, again, put this in parentheses, 0.08206 times 273. And I get my moles as being 0.0190 moles of the gas. So now that I know moles, now I can plug it in to my molar mass formula. So my 2.92 grams over 0.0190 moles, so 2.929 divided by 0.0190, and then I believe, 3 sig figs. My final answer should be 154, and then don't forget your units for molar mass are grams per mole. So 154 grams per mole is the answer. Good luck with number 11. And again, if you have questions, please email, please ask. All of your chemistry teachers are willing to do Google Meetups with you to go over some things, make individual videos reviewing things. We're just kind of here to help you all out. Have a great day.